Hey everyone, welcome to Mrs. Ross Does Math. Today's lesson is for Math 7. Our topic is using probability to predict. Alright, let's go ahead and get this started. So, once again, this is for Math 7. This is lesson 14. We are halfway through our final unit with this. So once again, this is lesson 14, and we're talking about how we can use probability to predict what will happen. Okay, so our essential question is, how can I predict an outcome using experimental and theoretical probability? Now, in lesson 13, we talked about the two different types of probability. The first is experimental. Experimental is the probability ratio of the number of times something does happen over the number of attempts. So when we're doing an experiment in science and we hypothesize that we're going to flip a coin 20 times, and out of that 20 times I'm going to get heads 10 times, when I actually go through that process and I figure out how many times I actually do get heads, that's going to go on top, and that 20, the number of attempts, is going to go down below. Now, theoretical probability is the number of times something could happen. So using that coin flip analogy again, my possible outcomes, there are two possible outcomes, because on a coin I have heads or tails. The number of times something could happen, well, if I'm hypothesizing that it could happen, 1 out of every 2 flips, then I'm going to get heads 1 out of 2, okay? So keep that in mind as we're moving forward. Now, we have the ability to use probability to predict what could happen in a similar situation too. So in your assignment today and later on this week with lesson 15, you're going to be using probability to predict what could happen in the future, or what could happen if that scenario continued, okay? So our first example is this. Sarah surfs with her friends. Okay, so she's gone surfing. She catches 8 of 20 waves. They stayed in the water for 50 more waves. How many of the 50 waves could her friend Mark catch? Now we're assuming that Mark caught the same number of waves as Sarah. Okay, so to begin with, it says Sarah catches 8 out of 20 waves. What is our probability here? Well, our probability is going to be the number of times something did happen, which was 8, out of the number of times she attempted, which was 20. Now, when we talk about probability, we always want to put this in a reduced ratio. Now, a number that can go into both 8 and 20 is 4, so I'm going to divide each one of these by 4. Now, when I do that, 8 divided by 4 is 2, and 20 divided by 4 is 5. So the probability of Sarah catching a wave is 2 waves out of every 5. That's how we could say that. Now, we're going to use this information to help us when we figure out how many waves her friend Mark could catch. Now, once again, we're assuming that Mark caught the same number of waves as Sarah. Okay. So, our next piece of this is we are going to create a proportion to find out how many waves Mark could catch. So we are going to set this up as our Sarah's proportion, which was 2 out of 5. And we're going to set that to what Mark could have gotten, which was 50. And we want to know how many waves he could catch if it was the same number as Sarah. So again, that's going to be up. So when we're setting this up, this is waves caught over our waves attempted. Okay? So our waves caught over waves attempted. Now here, we are going to have to cross multiply our two numbers. So I'm going to go 2 times 50, and I'm going to set that equals to 5 times x. Now 2 times 50 is 100, and that's going to equal 5x. Now I'm going to divide by 5 on both sides, and when I do that, I get 20 is equals to x. Now because this is a word problem, we need to state words in our answer. So we are going to state Mark could catch 20 of the 50 waves. Okay, so that would end up being our final answer. Now, as we get going with this, we're going to take a look at our assignment. Now, on your assignment, you only have 4 problems. Now, there happen to be a couple of pieces to each one of those problems, but it's still a shorter assignment. Okay, so if you have any questions on this at all, please pause, please go back and rewatch this video, please attend one of the math sessions I'm hosting throughout the week. I want to help you guys out any way I can. All right, so here we go. So keeping this in mind, we are going to go ahead and start our assignment. Now your assignment is lesson 14, and once again the topic is using probability to predict. Please make sure your name, today's date, and the class period goes at the top of each page. Please do that at the start. I'm getting some papers that the IAs are having to put names on when they're getting turned in, so I don't know if I can actually give credit where credit is due, so please do that. If you don't put the date, at least put your first and last name, please. I am recording this on the 18th. Okay, so now I'm going to do this on both pages. Okay, so now that my name is on both pages, let's read the instructions. The instructions state to answer each question to the best of your ability. Use the notes provided and be sure to also watch our video in YouTube. Just search Mrs. Ross Does Math. That's a hint because I'm not seeing many of you actually watching the video. You're just blowing through the assignments and it's not doing you any good. So please make sure that you take the time, watch the video that I'm going to post soon. Okay? Now, I'm going to go ahead and get started on numbers 1 and 2 with you, which means you are only going to need to do numbers 3 and 4. That's really working in your favor here, okay? So, let's go ahead and let's get this going. So, you plant 20 marigold seeds and 12 of them grow into flowers that bloom. If you plant 10 more marigolds, predict how many of them would bloom. Well, we need to figure out our ratio or our probability of the first 20 marigold seeds where 12 of them bloomed. So, once again, when we're working with our experimental probability, we talk about what does actually happen. So, 12 of our marigolds actually grew. So, I'm going to put my 12 grew on top. Okay? Now below that, I have my 20 seeds. These are the number of attempts that we had. Now, I need to reduce this. Now, a number that can go into both 12 and 20 is 4. So 12 divided by 20 is 3, and 20 divided by 4 is 5. So my probability that a seed will actually turn into a flower is 3 out of 5. Now I'm going to use that same ratio here when I'm looking at planting 10 more marigolds. Okay, so if 3 of my 5 marigolds turned from seeds into marigolds, I'm going to put the seeds on top, the seeds on the bottom, which would be the 10, and I'm going to put my I'm going to use M for marigolds on top. So once again, I'm taking my probability that 3 flowers will become flowers out of the 5 planted. Sorry, trying to get my words right there. And if I plant 10 more, how many of them will actually turn in flowers? That's my M. So now we're going to go ahead and cross multiply. So I'm going to have 3 times 10 And I'm going to set that equals to 5 times m. M, once again, is for our marigolds. 3 times 10 is 30, equals 5m, because 5 times m is 5n. I'm going to divide by 5 on both sides, and that's going to leave me here with 6 equals m. So that means that if I planted 10 more marigolds, 6 of them would bloom. So that's what we're going to write. If I planted 10 more marigolds, six of them would bloom. And that is our final answer. Okay? All right, so here we go. Moving on to number 2. Number 2 says, Cameron threw 3 touchdown passes in one game out of 9 touchdown pass attempts. Find the experimental probability Cameron will throw a touchdown pass when attempted. So once again, when we talk about experimental probability, we talk about what does happen over what could happen. Or sorry, how many attempts it actually happened. Sorry there. So once again, when we talk about experimental probability, we talk about the number of times something actually happened out of the number of attempts. So Cameron previously threw 3 touchdown passes. So we're going to go completed or touchdown passes. I'm going to write down touchdown success. So his touchdown success over his attempts. Now Cameron had 3 successes out of 9 attempts, which means that we're now going to go ahead and need to simplify this. Okay? So here, when I simplify 3/9, I get 1/3. So my ratio here is 1/3. Okay, so that is my probability. That's my experimental probability that Cameron will throw a touchdown pass when attempted. That means he'll have 1 success for every 3 attempts. Now, part B says Cameron has 12 touchdown pass attempts in a game. Predict how many touchdowns he will complete, okay, or he completes. So once again, we're going to take our experimental probability, which is 1/3. We have our pass attempts. Attempts was in the denominator, so we're going to have the 12 attempts in the denominator here. And that means we're going to have, I'm going to put a T for touchdown up top. Okay, so now I'm going to cross multiply. I'm going to have 1 times 12 is equals to 3 times T. I get 12 equals 3T. I'm going to divide by 3 on both sides, leaving me with 4 equals T. Now T was our touchdown successes. So we're going to write down Cameron had 4 touchdown successes. All right. Now, if you have any additional questions on this, please leave me a comment. Please send me a message. I am here to help any way I can. Thank you so very much for watching. This has been Mrs. Ross Does Math.